Use a normal approximation to find the probability of the indicated number of voters. In this case, assume that 90 eligible voters aged 18 to 24 are randomly selected. Suppose a previous study showed that among eligible voters aged 18 to 24, 22% of them voted. Find the probability that exactly 23 voted. So we want to first identify the values of n, the sample size, probability p, and then the complement of p, which is q, given that a success of voters aged 18 to 24 voted. So if we come back up here, we can see that the sample size is 90, so n is equal to 90. We know the probability of 22% is equal to 0.22, and q is equal to the complement of p, so 1 minus 0.22 is equal to 0.78. Now we want to be able to calculate the values of n times p and n times q. So we want to check. We know that n is equal to 90 and p is equal to 0.22. We want to verify that that's greater than or equal to 5. Again, n being 90 and q is 0.78. We want to multiply those together to see if it's greater than or equal to 5. Well, 90 times 0.22 is 19.80, which is greater than 5. 90 times 0.78 is 70.20, and that's also greater than 5. Therefore, the normal distribution is suitable for approximating the probability. Now what we want to do is be able to find the mean and the standard deviation. The mean is equal to n times p, and the standard deviation is equal to the square root of n times p times q. So we've already found the mean from the first part up here, because 90 times 0.22 is equal to 19.80. And to find the square root of n, which is 90, times p, which is 0.22, times 0.78 gives us the square root of 15.444, which rounded to 6 decimal places gives us a standard deviation of 3.929885. Now what we want to do is be able to draw a normal distribution that's centered around the mean, which is 19.80, and then draw a vertical strip area centered around the value of x equals 23. Now, since it is exactly 23, we're going to include 23 and shade between the continuity correction. So remember this chart that you have in our notes. Exactly means it's going to be in between those values. So let's go ahead and draw the bell curve. So here's our bell curve. You want to make sure you label everything on the bell curve. We know that the mean that we found to be is 19.80, and then 23 is to the right of that. So we're going to go ahead and put that as 23. So what we have is we're looking for what are the values to the left of that and to the right of that according to the continuity correction. So remember that the continuity correction represents the discrete whole number x by the interval of x minus 0.5 to x plus 0.5. Since we know x is 23, 23 minus 0.5 is 22.5. So that's the value to the left here. And then 23 plus 0.5 is 23.5, and therefore that is to the right of 23. And so what we want to find is the area that's in between. So again, as we stated before here, since it is exactly 23, we shade between 22.5 and 23.5. Okay, now we want to be able to do is find the z-scores that correspond to 22.5 and 23.5, and then rounding them to 2 decimal places. So if we draw our z-scale underneath that, we know that the mean for the z-scale is 0. So we're looking for a z-score here and another z-score here. So we're going to label one of them to be z1 and the other one's going to be z2. So let's go ahead and plug those values in to find the z-scores. So using, again, the mean of 19.80 and the standard deviation of 3.929885, let's plug in those values. So for Z1, we know we're using 22.5. So 22.5 minus 19.80 divided by the standard deviation of 3.929885 gives us 0.687043. And remember, z-scores need to be rounded to 2 decimal places, which gives us 0.69. So therefore up here, we know that this z-score is going to be 0.69. Okay, next, we want to find the z-score that's associated with 23.5. 23.5 minus 19.80 divided by the standard deviation, again at 3.929885, gives us 0.941503. And again, rounding that to 2 decimal places gives us 0.94. And therefore, 23.5 has a z-score of 0.94. So now what we want to do is find the area that's in between those two z-scores. So what we're going to do is we're going to be able to use StatCrunch. So we're going to go open up StatCrunch. Okay, and let's go ahead and go to Stat, Calculators, and then scroll all the way down to Normal. Okay, since we're looking for between the two values, we want to make sure that we select between. We know that our mean is 0 and our standard deviation is 1. So the value on the left side is 0.69, and the value on the right is 0.94, and then we're going to select Compute. And therefore, that's going to give us the probability that we're looking for. So recall that we want to round that to 4 decimal places. So again, find the area in between. That gives us 0.0715. Therefore, the shaded region in the graph is 0.0715. Hence, there is a 0.0715 probability that among the 90, exactly 23 eligible voters will actually vote.